Hello, my name is Ryan Beam, and I'm a student at the University of Kentucky studying economics and data science. In this series, I explore how data and tech is applied in real-world settings and how the field continues to evolve. Today, I'm joined by Brian Balagot, a senior data scientist at Amazon. Brian, thank you so much for meeting with me today.
Yeah, it's happy to be here and thanks for the invite.
Yeah, no problem. I really appreciate it. So just to kind of get us started, I wanted to kind of let you give an opportunity to kind of walk me through your career, kind of the pivotal moments, because I know you started with a degree in management engineering and then moved into ultimately data science now after some pivots. So I was just kind of curious how that unfolded and what were some of the meaningful inflection points along the way for you?
Yeah. Um, so I took up management engineering. It's really applied math for business. Because at the time when I was getting into college, I was just told that it was the hardest program. And I was like, okay, whatever it takes. And it was filled with about as much math as math majors. But what distinguishes it is that it has the application of math to the context of business. So it gave like fundamental courses that a business undergrad would go through, like accounting and marketing and all that stuff. But it also had like operations research and applied statistics. And as I was going through my program, I think it was in the third year of while I was in college. Um, my uncle shared this book with me called Scoring Points, which is a book by Tesco, a grocer in the UK. My uncle shared it with me because he at the time ran the chain of supermarkets that my family owned. And we were always thinking about how do we make this business better. And in scoring points, the crux of the story of Tesco is how they used their loyalty cards and customer data to change the way that they pseudo-personalized shopping. And then we're talking about a book from like, in the 1990s. And so, like coupons came out of, printed receipts, and people were mailed gift certificates. But Tesco was doing what Amazon Prime is doing now, because whenever Tesco would send their gift certificates over to people, it created peaks in their sales just like it was like, Christmas or whatever. And I read the book and I was thinking to myself, crikey, like, how can I apply stats at scale so I can change our business? And I couldn't because I didn't know how to code. And the infrastructure wasn't where it was, where it needed to be. And I just did whatever I could to apply the knowledge that I got from my undergrad in however way I could, given the constraints. But it's a chain of supermarkets. Wasn't the biggest chain, right? Like it wasn't Walmart scale. And eventually, when the Walmarts came to where our stores were, we decided to fold the business, and just since we owned the land, we turned it into a real estate company. And family is good, but I had the opportunity to exit without having the guilt of telling my family that I'm quitting the business.
Right.
And uh, I knew that what I wanted to do was to learn more about how I could apply it at scale. And it happened that, and this was in, I think, 2013. I was visiting the US because a second cousin of mine's husband worked in Facebook. And I was like, wow, this campus is really cool. Like the campus in Menlo Park. And I was like, do y'all hire like mathematicians and stuff? And he's like, you should read about data scientists. And so since then the seed was planted. The
Nice.
business closed, and I was like, you know what? If I don't do it now, I'm never gonna do it. So I took all of the money that I had saved, and with my wife's permission, I put it all into a boot camp in San Francisco, and did everything I could to get a job afterwards. And the first job, thankfully, the program ended in December. The first job was at IBM, that started in April. And ever since then, it's just been one job after another. Started at IBM, and I thought that that was fun. I did that for a year, at least getting a feel of applying things and talking to clients. And after doing a year of that, there was an opportunity to join a startup called Owlcam, where we built smart cameras that basically detected critical events around your car, namely break-ins, bumps, car crashes. And I think that is when data science became like really real for me because at IBM, it's like, you're begging customers for their data so that you can build cool stuff for them to sell to them because that's what IBM does as a client services company. But at Owlcam, it was like I didn't need permission from anyone to access the data that we had access to. And it was within the limits of my ability and creativity that I could create things for our platform. And I think one of the most fun projects that I ever had there, which is where I said like data science really felt like it was real, was when I was using the accelerometer and the microphone data to detect when car crashes were happening so that we could send an ambulance to where you were, since we had an API that fired if that crash was detected. It routed to a call center, and then they would call you, and then if you needed emergency services, we could get it to you. Um, and talking about inflection points, right? As startups do, that startup folded, and it just so happened that at the time, Amazon was very interested in pursuing a car camera, which we shipped in 20, I want to say 2021, 2022. So the team that made Owlcam, we eventually made the car camera for Ring. And after that, it's just been, and I was in Amazon, working on hardware, working on the time series algorithms that I did at Owlcam. And I was thinking to myself, like, if I'm going to be at Amazon, like, I want to play, I want to be where like the NBA is, right? And at Amazon, it's like the big league is in stores, right? Like the biggest retail commerce company of the world. And then I'm thinking, this is exactly what I wanted to do when I read that scoring points book, right? Like, how can I apply everything I know at scale? Because I already knew how to code because of that boot camp and all of the work that I did at Owlcam. And it's now like, okay, let's study customer data, make Amazon better for customers. And that's what I've been doing for the last 4 years.
So, yeah, that's super cool. And I think yeah, that's fascinating, how your pivots worked and especially how you kind of leaned into, what you're passionate about and how that you kind of let that direct you. And I think that kind of plays into my next question because coming from that background in management engineering that, like you said, it has that applied business perspective, which, I know a lot of data science has that as well. But being in some technical roles, where you kind of have to bridge the gap sometimes between the business world and then the tech side of things, how did that management engineering side kind of prepare you? And how's that helped you kind of approach data science now?
That's a really good question. I think one of the things that has helped me um, think about approaches to problems, which is grounded in my understanding of business. I think it helps in two ways. The first being a good understanding of costs, profits, and revenues. Because, for example, like one of the things that I'm working on is a predictive model right now. And one of the things that you want to do is understand how you make trade-offs between true positives and false positives. And if you have an understanding of how that affects customers and real costs that you might incur or maybe prevent based on how your predictive model works, then that's a grounding that you have because of your understanding of the science of the model, because of your understanding of the technicalities of how it works, and because of your understanding of what the business needs. And so I think that that business framing helps in that respect. Another thing that I think it's helped with as well is in understanding the customer side of things, which is why I really enjoy working at Amazon. It's a very customer focused, customer obsessed company. And so as long as the decisions and the model designs we make are very grounded in the customer experience, then having that, understanding of like how customers work, how business works, it gives me that ability, I think, to better communicate with non-technical folks. Like, why should we build something in a certain way? Why should we optimize for a certain thing? Yeah.
That makes a lot of sense. Yeah, that's really cool, and I know. speaking off of that and you talked about this a little bit earlier, going from the startup to Amazon, I know you kind of worked on some similar problems, but that's a big jump in scale. So I was kind of curious, how does that change even, from the theoretical to maybe just, to dealing with a big place like Amazon? How does that change how you approach even some of the same problems?
Yeah. Um, no, and you're right to call out Amazon scale because that is something that, like, having worked at Amazon, like, really can talk about, right? Like, big data at Amazon scale. We processed it and we survived. And I think what helped me a lot is that when I was working at the startup, I was the data guy. If
Mhm.
I needed to figure out how to scale a certain process, I had to figure that out myself. I had to figure out distributed computing in 2018 across multiple EC2s if I had to run a Python process because at the time I don't like even if Ray was popular then I didn't know about it. And so I just had to, work with scale with what I had. Um, and moving to Amazon afterwards, what I think worked out for me is that when I moved to Amazon, I was working on V1 hardware, I want to say for my first 2.5 years at Amazon. It was V1 hardware at Ring, and it was V1 hardware at one of the teams that I was at Amazon. And in both cases, with V1 hardware, you're not working with millions and millions of customers or billions of transactions in a month. Um, and so I had the understanding of scaling and distributed computing and all building data pipelines because I worked at that startup. It took that with me, but I didn't have to immediately apply it when I first joined at Amazon. So there was like that, I guess that cooling period, right? Like just getting to ease my way in. And then when I moved to stores, I think that the tools that we have are very established just for handling big data. Like we have Spark as a service, just makes everything easy. You don't have to stand up the cluster. The clusters are available. Pick the one that you want, fire it, and get back to work on other stuff. So um, I think that those components helped. And if I did have to do distributed computing, I think what's nice, I want to say over the last 3 years, and especially in 2026, is that I think the distributed computing like tools, Ray especially, has been very helpful if we just needed to seed a process across multiple CPUs. But also the ability to access distributed computing is so much easier in 2026 because of agentic coding.
Yeah.
And so if, 3 years ago, I had to really make sure that I was writing things in a fault recoverable way that's observable. Now I just have to tell an agent to do what I did 3 years ago, and it does it well, needing some more tuning, but you know, yeah. So that's how that worked.
Yeah, that's super interesting. So now to just kind of your day to day at Amazon as a senior data scientist, what does that look like? And what separates a good data scientist from an amazing one?
Okay. So I guess so two parts. I'll answer the first one, which is like, what is it like at a senior data scientist on the day-to-day at Amazon? So part of day-to-day, so I want to say there's a constant component to day-to-day, and then there's a changing component to day-to-day. The constant component for a senior data scientist is that I get to work with other data scientists on my team to drive projects and to move things along. And so in my case, I get to collaborate with two other data scientists regularly for two different projects. And that includes reviewing code, reviewing science approaches and analyses docs. And so that's a constant part, I would say, of the day to day. By constant, I mean like it doesn't happen every day. Like you could meet once a week or what have you. It depends. There's a cadence. It's a
Mhm.
constant part of the cadence. The changing component is for my own projects, which depending on the state that it's in, affects what I do on the daily. If we're close to shipping something and I'm in the middle of model development, like right now, then I'm on top of being sleep deprived. Also knee deep in understanding which architectures to use, which loss functions, which features. It's just like hard modeling.
Mhm.
And as we get closer to the end, then it becomes lots of documentation, writing science papers, because I need to present this to science leadership to get approval and alignment on our actually using this on a CX. And then maybe after that, towards delivery, it becomes MLOps and understanding whether the metrics that we're expecting are what's working out in our A/B tests. And if not, then, figuring that out once the results come in. And so there's a constant component, there's a changing component.
Right.
Yeah.
That makes
And
sense.
then to your second question about like what separates a good data scientist from an amazing one. Um, I think that table stakes in both cases would be like you you are both technically proficient, right? You have a high quality bar, right? Um, and so if you were both given random lead codes and all that stuff, you solve them, right? But I think what separates like good and amazing, especially in Amazon, is having that expert level understanding of the problem space. And that's one of the things that um, gives that data scientist the ability to lead others in solving that problem space. At Amazon, there are actually I don't know if you're familiar with the different job roles at Amazon. So and Google does this too, right? Like you have applied scientists, you have
Hmm.
data scientists, you have business intelligence engineers, you have economists. And economists and data scientists could be hired as data scientists at Netflix. Applied scientists could be hired as data scientists at Google and data scientists as product analysts at Google, right? Like each big company has their own definition of it. Um, and at Amazon, uh, uh, for data scientists at Amazon and applied scientists, the key distinction is that applied scientists like advance the limits of the scientific frontier. And so they're the ones who are creating the next gen versions of large language models and what have you. Data scientists, on the other hand, go deep into the customer understanding, go deep into the problem space. And so, yeah, separating good from amazing, I would say problem space understanding. Because if you understand the problem space, you understand what's driving, for example, customer abandonment, like more than anybody else, right? You understand the right levers because you really dug into the data. That makes you a leader for the problem space. Like you can go to the business, you explain the problem. You can go to applied scientists and say, here is the problem. What net new science solution do we need to actually solve it? And so, like not having that obsession with the data, not having that obsession with the problem space, and really being able to like break it up into its different actionable components. Yeah, it's because any data scientist can throw a data set at an agent nowadays, right? And be like, hey, cook something up for me, right?
Right.
And then just get mad at it until it looks good, right? But yeah, having that obsessed level of understanding of the problem space, being able to lead your organization
Mm.
because of that, that's what makes you fantastic.
That's a super interesting perspective. And it's one that, as I've kind of entered at least the tech field just a little bit, experimenting with data and starting to use data and AI and things like that, it is kind of something I've observed from, my position as an intern to the people who are there full time and, really advanced in their roles. And yeah, I think that's a really great perspective. And I haven't really thought of it that way. So I appreciate, you putting it into those words like that.
Yeah,
Now I kind of want to go back just a little bit to your time at IBM
yeah,
because I know you worked on kind of the applied AI team there, and you used natural language processing, recommendation systems, things like that, well before LLM era that we're living through now. So I was curious, as somebody who has that perspective, how do you see what's happening now?
Uh, I see it as like fundamentally amazing.
Yeah.
Because crikey, what was it? 2018, 2017. And we were thinking about like how do we create like a visual understanding of a document? And how do we synthesize key components of a document? And way back when, it was like, oh, cosine similarity,
Yeah.
TF-IDF, right?
Yeah.
And graph models on top of that representation. And you can get sentences that are similar to one another and maybe centroid sentences of a specific like community in a graph, right? Because um, that's what summarization was like. At least a part of summarization was like extractive summarization in 2016.
Hmm.
But now it's all and going through the motions, right? Of like, oh, LSTMs, sequence to sequence models, right? And evolving until attention is all you need, transformers, LLMs, right?
Yeah.
And so, yeah, a lot has changed.
Yeah. It's very interesting. It's an interesting time, like I said before, to kind of be entering this space. It's a bit
Mhm.
scary, but it is an interesting and fun time to be getting into it. So, as we kind of wrap up, I have like one last question for
Yeah.
you. And I know you've given me a lot of just things that I could take and reflect on that would be great advice. But now I was just curious, if you're in my shoes, 20 years old, studying econ, data science, thinking about a career in tech. What general advice would you give for me?
Um, yeah, become an expert of a problem space. I think I remember something that I think it was Jensen Huang who said something along the lines of, um, sure, we have all of these large language models now, right? But what we really need are experts so that these models are doing the right thing, right? Like we need experts in physics, we need experts in the material sciences and the true sciences so that these things will actually do what we want them to do. And so, you know, table stakes, right? Leet code, all of that, having that high quality bar for the analyses, getting the code right, getting the stats right. Those are all the table stakes, but having that expert level understanding of a problem space, yeah, that's what you should obsess over. And don't let any of that, I would say, like, if you can be an expert at the problem space and communicate your understanding really well, I wouldn't be worried about like LLMs taking over your job and all of that stuff.
Right. Awesome. Well, I really appreciate the advice. I think that's a very interesting like mental model to take through. So I'll definitely be reflecting on that and thinking about that a lot. So thank you again, for the advice, and I really appreciated, the conversation and everything.
Yeah, and thank you for having me.
Yeah,
Have a good
absolutely.
weekend.
You too.